Now, when we're going to evaluate the sine and cosine and tangent of all these different angles, there's something called the unit circle that's going to really come in handy. And there's going to be some memorization on your part. I will always give you a blank unit circle that you can fill out quickly. You'll get used to it. So here we go. All right, we're going to start with a unit circle. Now, a unit circle is simply x squared plus y squared equals 1. That's the equation of a circle centered at the origin with radius 1. So let's draw a picture of that. We're going to study conic sections later on in the school year. So there you go. We've got a circle, and it has a radius of 1. So if I go from the center out to any point on this circle, the radius will be exactly 1. So let's say this is some arbitrary point. I'm going to call this point xy. xy. Okay? And then what I'm going to do is I'm going to drop a perpendicular down to the x-axis so I can create a right triangle. And the bottom length of this right triangle is exactly x, because I'm at the point xy. And then the height of it is y. And inside of here, we're going to call this theta. I think your book calls it t, but I like to just use theta. So this is the angle theta. Now, let's use our values, or our SOHCAHTOA that we did last week, and let's find out what sine of theta is equal to on a unit circle. So, still going to use SOHCAHTOA, right? So sine is opposite over hypotenuse. And what do we get? Y. You just get the y value. Okay? All right, cosine of theta is equal to x, adjacent over hypotenuse. So it's going to be the x value on the unit circle. Tangent is equal to y over x. And you could also say that tangent is equal to sine over cosine. Do you see that? If sine is y and cosine is x and tangent is y over x, then tangent is also sine over cosine. Those are going to be one of our identities that we're going to learn later on. All right, then let's do the reciprocal functions. Oh, by the way, tangent of theta is y over x as long as x doesn't equal what? 0. At 0, it's undefined. When x is 0, tangent is undefined. Okay, and then let's do cosecant. Cosecant's going to be the reciprocal of sine. Sine is y over 1, so cosecant would be 1 over y, as long as y is not 0. If y is 0, then cosecant is undefined. Secant of theta is going to be 1 over x, when x is not 0. And cotangent of theta is x over y, when y is not 0. Okay, so that's what it's going to be. So basically, if you have a point on the unit circle, then if you take the value sine of that angle, you will be the y value out on that circle. So let's write that down real quick. So our points on the unit circle are going to be cosine of theta, sine of theta. Okay. On the unit circle, x, y. Now, I'm going to give you some important values on the unit circle. By the way, the unit circle, if you were wondering, the entire thing is in your book on page 346. Okay, if you wanted to take a look at that, it has all 4 quadrants. I only make you memorize quadrant 1, and then you'll use All Saints Trust Christ to get all the other values. So here we go. Let's go ahead, and we're going to draw our unit circle again. And as you know, there are going to be some important angles, like your special triangles that you had. There are going to be special angles on your unit circle. So let's draw one up to here. This right here is going to be the angle pi over 3. Okay? In the middle of this quadrant, right in the middle, is 45 degrees, which is pi over 4. And then over here is a very small angle, which we're going to call pi over 6. Okay, so I'm doing this in radians. So pi over 3 is 60 degrees, pi over 4 is 45, and pi over 6 is 30. Now, on this unit circle, and using your special triangles that we learned last week, at pi over 3, at exactly pi over 3 on the unit circle, that is the point 1/2 rad 3 over 2. This point right there. I could show you a proof of that. I could show you that it's equal to that because of our 30, 60, 90 triangle, but you believe it. Okay, at pi over 4, if you can visualize a triangle, and if you dropped a perpendicular straight down, you would see that x and y are exactly the same, and this is going to be rad 2 over 2, rad 2 over 2, which we just saw in our homework. That was one of our answers. Yeah?
So for the unit circle, is the radius always 1?
Radius is always 1. Yep. And then pi over 6 is just going to be the exact opposite, just these switched up here. Instead of 1/2 rad 3 over 2, it's going to be rad 3 over 2, 1/2. There you go. Okay? All right, let's look at some other important points on this unit circle too. Right here, at theta equals 0, or theta equals 2 pi, whichever one way you want to see it, this is the point 1, 0. X is 1 and y is 0. This up here, at pi over 2, this is the point 0, 1. X is 0 and y is 1. Over here at exactly pi radians, on the unit circle, we have -1, 0. And then down here is 0, -1. Those are going to be important points too. Okay? And that's pretty much all you have to have memorized. I know it's a lot, but there's kind of a nice way to remember this too. If you see here, this is 1, 2, 3. 1, 2, 3, and they're all square roots. Square root of 1 is 1, square root of 2 is square root of 2, square root of 3, and then it starts down here, 1, 2, 3. So it goes 1, 2, 3 going down, 1, 2, 3 going up, and everything's the square root, and everything's over 2. Okay? So it's not that hard to memorize. You'll get used to it. You'll start to really love it. So let's go ahead and let's do some problems now. Okay? We're just going to stay in quadrant 1 for right now, just to get used to it, and then we'll jump into 2, 3, and 4. All right, so let's go ahead and we're going to evaluate the cosine of pi over 6. To find out what the cosine of pi over 6 is, we've done this already. We did this using our 30, 60, 90 triangle, which, you have to draw them and whatever. The unit circle is going to be on a little piece of paper that you're going to fill out every time you take a quiz or test from now on in trig. Okay? And so you don't have to. If you don't use it, you don't have to, but you should. All right, so the cosine of pi over 6. So you go to pi over 6, and what value is cosine? On the unit circle, cosine is x. Okay, so you go to pi over 6, and what is x at pi over 6? Rad 3 over 2. That's it. Okay, so we evaluated the cosine of pi over 6. You go to the unit circle at pi over 6. Our value there is rad 3 over 2, 1/2. So cosine of pi over 6 is rad 3 over 2. All right, let's do another one. How about the sine of pi over 6? The sine of pi over 6. So remember, cosine is the x value, sine is the y value. So what would the sine of pi over 6 be? 1/2. 1/2. So you go to pi over 6. It's all filled out right there for you. Good. All right, how about the tangent of pi over 4? That's a pi. The tangent of pi over 4. Sorry, I messed up that pi. Now, what is tangent again? Tangent is y over x. So you're going to take the y value at pi over 4 divided by the x value at pi over 4. And what is rad 2 over 2 divided by itself? It's just 1. So tangent at pi over 4 is simply 1. Your calculator will do that too for you. We're not using our calculator. Okay. How about, let's try a harder one. Let's do the cotangent of pi over 3. Cotangent of pi over 3. You're going to have to work for this one a little bit. So you got to remember what cotangent is. Tangent is y over x, which means cotangent will be x over y. So you go to pi over 3, and we're going to do the x value divided by the y value. Now, of course, I'm not going to let you leave it like that. That's disgusting. So what we're going to do is we're going to take the bottom fraction. Remember when we divide fractions, you take the bottom one and flip it and multiply. So this is the same thing as 1/2 times 2 over rad 3. 2's reduce, leaving you with 1 over rad 3. And then we rationalize, multiply top and bottom by rad 3. So we get rad 3 over 3. Some people memorize these. Those people are crazy. I can't memorize stuff like this. Like if someone says cotangent of pi over 3 and they know it's rad 3 over 3. I don't know how they do that. Okay, so you feel pretty good? Let's do one of those special points around the outside here. Let's go with what is the sine of pi over 2? What is the sine of pi over 2? Now remember what sine is. Sine is the y value on the unit circle. So the sine of pi over 2 would be 1. Sine of 90 degrees is 1. How about the secant of pi over 2? Now let's remember what secant is. So cosine is the x value. Secant will be the reciprocal of that. So you would get what? Well, cosine is 0. What's the reciprocal of 0? The reciprocal of 0 is undefined. And so you would say that the secant of pi over 2 is undefined. Don't write your answer as 1 over 0. You'll write it as undefined. Okay, are you ready to go to all the quadrants now? Yes, let's do it. So what's going to happen is on the unit circle, we're going to have other angles going all the way around, and we're going to use their reference angle. So for example, if I needed to find where 5 pi over 6 is, 5 pi over 6 is over here. Okay, this angle that goes all the way to there is 5 pi over 6. You're going to have to get used to these fractions. It's 1 pi over 6 short of 6 pi over 6, which is a full pi. Do you see that? You have 1, 2, 3, 4, 5 pi over 6. But we don't have to memorize what its point is because it's going to have the same point as this pi over 6. It's going to have this same point, rad 3 over 2, 1/2, except since I'm in quadrant number 2, my x value is negative. But I don't even care about that either. So for example, if I needed to find, let me show you the way I do these. I'll put it up here. Number 2. If I needed to find the cosine of 5 pi over 6, this is what I do. I go to its reference angle. Now its reference angle is really easy to see. You know what it is? It's that right there. See where I circled it in blue? Its reference angle is pi over 6. So what I do is I go to pi over 6. I find out what cosine is there. Cosine is rad 3 over 2. And then I ask myself, what quadrant am I in if I was actually at 5 pi over 6, the angle I want, not just the reference angle of pi over 6. What quadrant is this? This is quadrant 2. Is cosine positive or negative in quadrant 2? Well, all saints trust Christ. Only sine and its reciprocal are positive, so cosine would have to be negative over there. That's how I get the answer. Okay, I don't want to memorize. Do you know how many there are? Let me show it to you. I'll show you my book real quick. You have the same picture in your book. It's right here. Do you want to memorize all that? Oh, you don't. So you memorize quadrant 1, and then you think about where they're positive or negative, and that's it. Their sign's going to change. So let's try another one of those. That's A. Let's do B. Let's see. Let's do sine of, what's a good one? 4 pi over 3. Sine of 4 pi over 3. Okay? So To figure out what sine of 4 pi over 3 is, I want to know what the sine of its reference angle. What is the sine of pi over 3? Can you see what the sine of pi over 3 is? It's rad 3 over 2. So you go to pi over 3, and you head over to the y value. Okay, so it's rad 3 over 2. Then you have to decide, is this going to be positive or negative? Well, do you know what quadrant 4 pi over 3 is in? Yeah, it's in quadrant 3. Because it's an entire pi and then 1/3 more. That's where it is. And is sine positive or negative in quadrant 3? It's negative. And that's your answer. Do you like these? Aren't they fun? No? All right, you try this one. Kind of all over the place here, huh? Number 3, evaluate. Let's do now the cotangent of 3 pi over 4. You try this one. I want to see if you can get this one all by yourself. Did I forget to record? We got -1. Oops. Okay, yeah.
Is that quadrant 1 or 2?
This is quadrant 2.
Oh, okay.
Yeah. Did I say 1? How is it quadrant 2? It's 3/4 of a pi. So here's a whole pi, and then 3/4 would be 1/4, 2/4, 3/4. I know. You got to get used to it. You got to get used to the fractions too.
No, it's just that I'm not used to the
Oh, this just being pi, huh?
that just being 1.
It's 1. Yep, it's pi. Okay, so then let's go ahead and evaluate what is the sine of 2 pi. What is the sine of 2 pi? This one's pretty easy. Especially if you have the unit circle right there. Sine is the y value. You go to 2 pi, which is all the way around. And then the point there is the point 1, 0. So sine of 2 pi is 0. Okay? That would be on your calculator too if you wanted to. All right, what about negative? We haven't done any negative angles. How about the cosine of -5 pi over 6? Cosine of -5 pi over 6. It's done the exact same way. Bless you. You need to look at the reference angle, and the reference angle here is pi over 6. And then you go to your unit circle. You go, right, what's the cosine of pi over 6? There it is. It's rad 3 over 2. So I'm going to write that down right away. I know that it's going to be rad 3 over 2. What quadrant is -5 pi over 6 in? 3? 3. It's negative. So we're going the opposite direction. 5 pi over 6 would be over here. See, it's just shy of a whole pi, 6 pi over 6, which is 1 pi. So it's a little bit shy of that. And so we know that cosine is negative in quadrant 3. You would have gotten the same answer had you thought it was quadrant 2, because cosine is also negative in quadrant 2. All right, do you feel pretty good? You're going to practice some of these tonight? Okay, degrees 1. All right, let's do 1 degrees. Let's do the sine of 300 degrees. And here's the part where you decide that you like radians better. Finally. All right, where is 300 degrees? It's over here, and its reference angle is 60 degrees, right? Which means that this is going to be, I mean, I'd rather write this in terms of radians, okay? But 60 degrees is pi over 3, so its reference angle will be pi over 3. So we go to where pi over 3 is on our unit circle, and we get rad 3 over 2, but we're in quadrant 4, and sine is negative in quadrant 4. Yeah, there you go.